Hey, Rosário.
Hey Ahmed, how are you?
I'm good, man. Good to see you.
Good to see you too.
How you doing?
I'm fine.
Good. Okay. You can present your slides.
Okay, let me share them now.
Okay, looking good. I'll leave the stage to you. Over to you.
Okay, thank you very much. Hi everyone, my name is Rosário Fernandes. I'm a GDE for Firebase, and I'm also a mobile app developer at a company called MostDevs. Something that I also enjoy a lot is contributing to open source, and one of my most recent contributions was on a library called Firebase KTX, which is actually what I would like to talk to you guys about today. So before we start, let's make sure we're all on the same page, and let's make sure we all know what is Firebase. So in short, Firebase is a platform for app development, or mobile app development to be more specific, where you have many different services all integrated into one single platform. So we have things like a database, we have an authentication system, we can have a service where we can store our user files, or we can maybe do crash reporting and stuff like that. So it's one of those platforms that are usually called backend as a service. And this platform is very specific to mobile apps. So we have SDKs for Android, for iOS, and for the web as well. And those SDKs for Android, they were written in Java. But as you may already know, in Google I/O 2019, Google announced that Android is now Kotlin-first. So even though Kotlin has good interoperability with Java, some of the code you write may still not be very concise and idiomatic with the Kotlin language. And that's why we came up with the Firebase KTX libraries. So before I speak about those libraries, I would just like to say that all the views and the opinions that I'm sharing here are my own. They do not reflect those of the Firebase team, which means if you ask them about those libraries, they will probably share different views and different opinions from my opinions. So let's say you're using the Java SDK to maybe create a dynamic link. This is what the code would look like. As you can see, it's just a simple link with some Android parameters. And if you were using the Firebase KTX libraries, there would be something like this. As you can see, the code becomes a bit shorter. So this is just one of the examples of how can Firebase KTX improve your code. So I'll be showing you some of the features that we used when we were creating Firebase KTX, and how you can also use them if you want to maybe improve some other Java SDK. So I'll be going through each one of those features, starting with Kotlin extensions. So Kotlin extensions is actually the core of the library. After all, KTX stands for Kotlin extensions. There are two types of extensions you can create. One is an extension property, which allows you to add a new property to a certain class without having to inherit from it, or without having to extend that class. And the second one is extension function, which allows you to add a function to the class without having to extend from the same class. So as you can see in this first example, we were adding a new property to the string class, and to do that we simply we declare it as if it was a regular property, saying val, and then we tell it what's the class we're extending, and we add the property. In this case, I'm adding last char, and we then assign this property to something else. So last char, I'm assigning it to the last character of the string. Same thing with the extension functions. You declare it as if it was a regular function, except that you actually pass the class that you're extending, and then you tell it the name of the function, and then you simply specify the function body or what this function is doing. And when you're about to use the function, as you can see, you use it normally as if this function or this property were part of the class, but in reality, you didn't really need to extend the class or anything like that. Next, what we did was create object declarations. So this object keyword in Kotlin is widely used, not only for object declarations. There are also more usages for the object keyword, but in those libraries we used only to create a single class using the singleton pattern. So if you're coming from Java, you probably already know this pattern, where you have one single class, and then to use it, you don't really need to create a constructor. Instead, you just use static methods on it. So here's an example of what an object declaration looks like in Kotlin. So let's say we have a class named coin. We have a property for us to see the value of that coin, and then we have some functions that can help us modify its values or access its values. Sorry. And this is how we use them. As you can see, we're not calling any constructor here. We're not creating the object. We simply use it. This is very similar to the singleton pattern. And in Firebase KTX, what we did was simply create an empty class called Firebase. There is no function, there is no property inside it, and that's because instead we created some extension functions for it, and extension properties as well. So for example, here we have a property called database, which basically gives us the instance of the Firebase database. We have a property called Firestore, which gives us the instance of Cloud Firestore. And in some very specific cases, in order to get an instance of some products or some services, we actually need to pass it an argument or a parameter. And to do that, we created extension functions for those products, as you can see here. And then this is how you would use the properties and the functions. So as you can see, before we used to do Firebase database.get instance. Now you simply need to do something like Firebase.database, which is a bit short. Next, we have inline functions. So usually when we write functions in Kotlin, we can actually pass functions as arguments to another function. And in order to do that, the Kotlin compiler usually allocates some memory for that function to be stored. Now, if we declare those functions as inline, we're telling the compiler not to allocate any memory for it, but instead copy the function as it is and use it inside another function. And by doing that, you can actually take advantage of another feature which is called lambda functions. So as you can see in this example, we've created a function called remote message, and we're passing another function called init to it. This is a function with no arguments, and it also doesn't return anything. And in order to use this remote message function, you can see here we're passing the string as a parameter, and then we're passing the other function as a lambda function, which makes it a little bit better to use. Next, we have array-fi type parameters. So sometimes when we're creating functions, we might want to specify a type for that function. So when we're using the Java SDK in Kotlin, for example, for Cloud Firestore, we would probably have something like the snapshot, and there is one function called toObject, and we want this function to convert our snapshot into another object. And to do that in Kotlin, we would use this code. So it says toObject, and then we have the class, and then some extra verbose here. So let's say class Java, which is actually necessary in Kotlin. But by creating a specific array-fied function, this one that you can see up on the top here, we would no longer need it because we specified that we are array-fying a type. So we would instead of using this, all these variables here, we simply need to call to object and then pass it the type here, and that's it, basically. I feel like this is way more simple and way easier to understand than this previous example. One more note here is that in order to use the verify type parameters, we actually need to use the inline keyword, which I spoke about previously. Type-safe builders. Those are the same from the first example I showed you earlier at the beginning of the presentation. So I think this DSLs are very common in Kotlin. So it's what allows us to use this hierarchy, as you can see here. So we're creating a dynamic link, and inside this dynamic link, we specify that we're using Android parameters, specify the parameters, and we can also add iOS parameters and then specify them. And by using this type-safe builder, we were not creating builders the same way we do in Java, where, as you can see, it's just like create a builder, add its parameters or arguments, and then call builder.build and all that verbose. It becomes something shorter like this. This is one of my favorite features. It's called destruction declarations. So if you come from a language like JavaScript, for example, this might be familiar to you. Let's see in this example, up top, let's say we have an upload task and we're listening to progress changes on this task. For that, the Firebase Java SDK provides a snapshot, which we can check properties on that snapshot. So for example, we can try to get the byte transferred property, and then we can get the total byte count property from that snapshot as well. And then we can use those properties to maybe calculate what's the progress on this upload task. Using the Firebase KTX, you can actually destructure this snapshot. So you can say, I only want to get the bytes and I want to get the total as well. And then you just simply use those properties to calculate the process. As you can see, this reduces a number of lines on your code. But how did we do that? In order to destructure a class, we need to declare a function or many other functions called components. So in order to get the bytes transferred, we declared component 1. So this is the class from the snapshot. So we are declaring an extension for it called operator fun test snapshot.component1. We're assigning it to the bytes transferred property. We then assign component 2 to another property, the total byte in this case. And then you can assign component 3 to something else, component 4 up until component n. Next, we have sequences. Sequences are actually part of collections in Kotlin. So in Java, we also have a wide number of collections like arrays, maps, and everything else. But Kotlin actually adds one more collection called sequences, which is very similar to lists. But the difference is that process elements in a collection is done lazily. So I'll show you some examples and I'll explain in a bit how this happens. But I have some snippets here that I wanted to show you, which shows us how to create a sequence from maybe elements from a real-time database node, or maybe results from a query snapshot on Cloudflare store. But let me tell you a bit about sequences. Let's see, for example, here we have a list. We're not yet using sequences, we just have a list. So let's say we have a list of words, and we want to do some operations on this list. So first we might want to filter the list and only get the words that have length greater than 3. After filtering, we might want to map it and change its value to its actual length. And at the end, we want to take only the first 4 words. So this is what it would look like when this list is being processed or when those operations are happening. So first we have the list, and then we filter it, the ones with length greater than 3. As you can see, are quick, brown, fox is not, so fox is not here, jumps, over, it doesn't have greater length than 3, so it's not here. And then we have lazy, and dog is also not here because it's what we were filtering on. So once we're done with the filtering, we go to the map function, and the map is simply converting the word into its length. So quick becomes 5, brown becomes 5, jump becomes 5, over becomes 4 because it has length 4, lazy becomes 4. And then we were saying that we only need to take 4 words. So take 5, that's 1, we take 5, that's 2, take 5, that's 3, we take 4, that's 4, and we're done. As you can see, this takes a lot of steps, I would say around 22. But if we were using sequences instead, as you can see, we have a list, and we convert this list once, and we will apply the same operations. So we filter only the ones with greater length than 3, we map it to its length, and then at the end we take 4. Now, since those are now lazily processed, what would happen is it won't go through all those processing steps one by one. Instead, it will wait for this terminal operation to happen, which is when we convert it to a list. So let's see. First, we have it goes through each one of the words one by one. So first, it starts with this, and since we're filtering it to only get the values which have length greater than 3, this is not valid. So it goes on to the next one, which is quick, and it sees that quick is valid, so it passes the filter, and then it tries mapping it, and it works, and then it tries to take it. So we never took anything, so it knows we have to take 4, so we never took anything, so this will be our first. We're taking 5. Next, it goes to the other word, which is brown, checks its length, it's fine, then maps it, and then takes it, because we need to take 4, we only have 2 so far. Then it checks the other word, fox, and as you can see, this is not valid, it doesn't pass the filter. So you go on to the other word, you don't really need to try doing the map or take or anything. So this word is also valid, and it takes 3, and then it goes on to the next word, which is over. It's valid, it takes, and as you can see, it's already taken 4, so it doesn't really need to go through the rest of the words, such as the, lazy, and dog. And as you can see, this takes less steps than the previous example that I showed you. So now let's talk about the features that are not present in the Firebase KTX libraries. Those are features that you might want to use since they're packaged. They come with the Kotlin language. First, we have coroutines, which are called lightweight threads. As you may know, recently Android has deprecated async tasks and some of its services. So coroutines can be a good alternative for background processing. Some people would say this is very similar to what we have in other languages. With, for example, in JavaScript we have async and await, but in Kotlin, async and await are not specifically keywords. Instead, we have a keyword named suspend, so that you can create functions. You can create suspend functions. I mean, so you're basically telling the compiler that those functions can be suspended and returned at a later point. And coroutines can be a great way to escape callback hell. So if you've been working with callbacks, you might know about. See an example. So let's say we have a user document for this user named John, and we want to maybe get information about John first, then try and get information about John's friends. And this information about John's friends might be in a different collection somewhere. So in order to get data from both collections, we would probably need a success listener or a callback. So first we would start with John, and then we would try to get data from the friends collection. And then at the end, we would put this data together and display it in our app. So as we're using two callbacks here. So first for John, and then inside this callback, we have a second callback for the friends. And if we needed more data, we would probably be adding callbacks and callbacks and callbacks, and eventually end up in callback hell. So coroutines can actually help us avoid that. We can have like a suspend function. You would use a try-catch statement to actually catch exceptions, any exception that might happen. And what we would do is we would use this await extension function, which I'll show you in a bit where this comes from. We'll try to access this document. So let's say John's document. We would get its value, and then we will try and access his friends collection, and we get its value. And in the end, we would just simply show this information in our app. So as you can see, this code looks more synchronous, and you don't really have any callbacks. So if you need to maybe read from more collections, you would simply do it here, and you wouldn't end up in callback hell. So where does that await function comes from? It's not available on the KTX libraries, but it's available on this library called Coroutines Play Services, which was created actually by JetBrains. So if you want to use coroutines with Firebase, I absolutely recommend you using this library. You simply need to add it to your Gradle file. So next up, we have a synchronous flow, which is very similar to coroutines, but instead of returning one single value, we actually can return multiple values. So let's see a very simple example. Let's say we have a function named simple, and this function simply returns us with a list of values. And then in our main function, we can maybe print those values. So this would print 1, 2, 3. But now let's say we want to compute those values before printing them. One way we could do this is by using sequences. So we would have this function creating a sequence by using this sequence builder. And then for each one of the values, let's say we are computing something here on this function. And then once that's done, we simply yield that value for our main function to use it. But the problem with using sequences in this case is that it would block the main thread. So let's say that this computation is taking 100 milliseconds. In order to compute the 3 values, our main thread will probably be blocked for like 300 milliseconds, which might not be so good for the user. Another way we could do it is by using maybe. So every time we need to compute something, we would simply suspend that computation for a later stage. But the problem with this is that we're returning a list, and in order for us to have all the values computed, we would actually need to have all the values computed before returning the list. And this is also not good because as you can see, the user would once again need to wait for the computation to finish in order to see the values. So asynchronous flow should help us solve this issue. And how do we do that? We can use a flow builder, which is this flow extension function. We do our computation here, and once our computation is done, for each element, we always emit this element. So that means if we are done with the first element, we emit it. Once we're done with the second element, we emit it, and so on. And on our main thread, we would need to launch a coroutine, because flows is tied with with coroutines, and we would need to collect all the values that are coming from the flow. So how is this better than the previous example? Because every time a value is computed, we're emitting it. We're not waiting for all the other values. So we're always displaying it to the user as soon as the value is computed. We don't really need to wait for everything to finish computing. Now, how can this be used with Firebase? There is this was actually suggested to be added to Firebase KTX. I hope it gets added soon. If you're on GitHub, you can check out this link. There is this pull request number 1252, which is actually it actually contains this code, which uses a callback flow to create a flow where we can get values from a Firestore collection. But why did this code not get accepted yet? That's because this function callback flow is still experimental. So usually Firebase doesn't ship any experimental functions unless it's an alpha release or something like that. So we can't really have a callback flow in the KTX libraries until it becomes stable. But if you would like to try out Flow with Firestore before it becomes stable, you can go ahead and copy this code to your app and try it out. So next we have Silk classes, which is a feature from the Kotlin language, and it's very similar to what we know as enums. So we could have, for example, let's say a class called result, and this class might be able to have different states. So let's say result can have a success state, where we could maybe once it's successful, maybe we could use the data in that state. If it's an error state, we could maybe check what caused the error, what's the exception going on there. And we can also have in progress state. So let's say this result is still being processed or is still being loaded, so we don't really have anything to do, but maybe it's a state that we also want to handle. So how do we check which state is there? The same way as enums. So you can use an when statement or maybe an if statement and check if this result is success. We try to access this value, which is data. If the result is error, we can try accessing the exception and checking what's going on. If the result is still in progress or is still loading, there's no value, but we can also handle this in our when statement. Now, how can this help us with Firebase? So in the real-time database, there is one specific listener that I don't like particularly, which is the child event listener. And that's because the child event listener is an interface with 5 methods. I'm talking about this method on child added, on child changed, on child removed, moved, and canceled. So why don't I like this is because when you're trying to use the listener, even if you only care about on child added, like in this example, I'm only using the onChild method function. I don't really care about changed, removed, or anything else. I'm just leaving them empty. We still need to declare all the functions, which is a lot of code that I'm simply not using. So we could use Silk class. We could create maybe a Silk class called child, and then have different states for it. So let's say child we'd have added, changed, removed, moved, and canceled, which are the same functions as we have in the child event listener. And as you can see, for each state, I'm passing the same arguments that we have on the corresponding function. And how would we use this class? We could maybe use this in conjunction with flows. So we could create a callback flow that every time one of the functions is triggered, it simply calls offer to tell the flow that there is a new there's a new value being emitted. There is a new child here. Either it was added or changed, or I omitted, removed, and moved for it to fit on the slide. But you would also have those functions here. And yeah, we would create a callback flow. And how would we use it? We could simply call our database reference, we access this flow, and we start collecting. And as you can see, like I said, I only care if a child was added. I don't really care about everything else. So I'm only using an if statement here. So I check if this child was a child added, I then use its value. And as you can see, this code is much shorter than the code we had previously, where we had to actually overwrite all the 5 functions from the child event listener. So I have two specific functions, which I added just as a bonus to this presentation. First, there is this function created by some member from the community named Part. He actually wrote a blog post talking about this, which you can check out in this link. So the function is pretty simple. What it does, it starts Firebase Performance Monitor, starts a trace with a specific name, and it traces everything that is inside this trace. So we could maybe run an HTTP request or something else here. I really recommend checking out this blog post if you want to learn more about this code and how he did it. And next, one more bonus is when you're setting custom keys to Firebase Crashlytics, which you can do using the pair Kotlin constructor. This is what the code looks like, but I'll show you what it looks like when you're using it. So it's something like this, which is much easier than setting one custom key one custom key at a time. I mean, because usually what you would do is call set custom key for one value and then set custom key to another value and so on. So it becomes instead you just set a group of keys all in once. And I've shared some links here if you want to know more about the KTX libraries or the Coroutines Play Service libraries. So be sure to share those slides with you so that you can take a look at all the links I've shared. And that's all from me. Thank you very much.
Great talk, Rosario. Thank you so much.
Thank you.
All right. So I'm not seeing any questions that are being posted. So, oh wait, there might be one. No, sorry, there aren't any questions. Yeah. So, thank you so much for your great talk, man. I hope you don't
Thank you for having me.
have to rush to another one now, do you?
Sure thing.
Cool. All right. Cheers, man.
Okay. Thank you. Bye.
Bye.